Hi there, welcome to this introductory video tutorial in Python programming. This tutorial, the subject of this tutorial is going to be primitive types and arithmetic operators. But before we get started, I'm just going to talk you through this software that I'm going to be using to write Python code in this and subsequent tutorials. This is what's known as an integrated development environment. It's basically a software program that helps developers, computer programmers, write their code. It's called, the one I'm using here is called Spider. There are others available. If you look at the main window here, you'll see we've got three different window areas. The main window on the left here is essentially a text file editor. Python programs, like all computer programs, are just characters typed into a text file. And this window here is where you can write that code, type into your text file. This window down here in the lower right hand corner is the console. So if you run a Python program that's written in the file here, any output that program gives will appear in the console. However, you can also, if you just want to execute a single line of code, you can actually type it directly into the console, and that's what we're going to be doing today. Up here on the top right, we've got some other windows: Outline, File Explorer, Object Explorer, Variable Explorer. I'm not going to explain those in detail now. We'll use them as they come up in subsequent tutorials. There are more windows as well. If you come up here to the menu and you select View, Windows and Toolbars, you'll see I've only got selected about half the windows that you could possibly select in Spider. So you can actually create and view more windows that do more things. But today we're just going to be mainly writing single lines of code and typing them in the console. So I'm just going to make the console nice and big. I'm also going to make the text larger so it's easy to view. So the first thing I'm going to do, the first line of computer code I'm going to type into this console is this: A equals 9. Okay. So what I've done here is created a variable called A. And I've assigned it, equals in computer programming means assigning, I've assigned it a value which is 9. Okay, so what this means is an object has been created within the computer's memory, within the RAM of the computer. The object has the value 9, and the name which we use to refer to this object, we've called it A. So 9, the number 9 is the object which is stored in the computer's memory, and A is the variable. It's the name that we use to refer to that object. And so now it's in there, I can get it back out if I want to view it. I can just press A, type the variable name, press return, and I get back the object 9. Now, any object that's stored in the computer's memory has to have a type. And I can inspect the type of the object that's referred to by variable A by using this command in Python, type A. Okay, and I press return, and it tells me that the object is an integer. It has the type int. And Python automatically assigned the type integer to that object because it recognized that 9 is a number and that it doesn't have any decimal points in, so it gave it the type integer. So integer is one of 4 primitive types we're going to be looking at in this tutorial. Another one, if I create a different variable called p and I assign it an object 2.7 and I get it back out of the memory to look at it, p equals 2.7, and I look at the type, Python has automatically created an object with the type float. Okay, a float means a floating point number, and it's the way that a floating point number is the way computers store numbers with decimal points in them. Okay, So we've got variable a, which is an integer with value 9. We've got variable p, which refers to an object, a float with value 2.7. Okay. I'm now going to create a new variable, m, and I'm going to assign to that a message, a word. Okay, I'm going to say hello. I've noticed how I have enclosed the word hello in quotation marks. This tells Python, these quotation marks tell Python that what I am defining here is not a number. I don't want it to be a number, I want it to be what's called a string, a collection of characters, so a word or a sentence or a single character, or as long as you want, a book even. Okay, so I'm creating this variable m. An object has been stored in the computer's memory, and that object has type m. Type m has type string. Okay, and if I inspect the type, it returns str, telling me that the variable m points to an object in memory which is a string, and that string looks like this, the message hello. Okay. The fourth and final primitive type that we're going to look at in this tutorial is this. I'm going to create a variable called y, and I'm going to assign to it true. Okay. Now notice I typed true, I haven't put it in quotation marks, and the Python console has sort of automatically coloured in the text of the word true, because it's recognised that true is a special kind of command in Python. It refers to a particular type of object called a Boolean. And if I inspect the type of my variable y, the object in memory to which y refers is a Boolean, and it tells me bool here. Okay, a Boolean is a very simple type of object in memory. It doesn't take up very much memory at all, because it's just a 1 or a 0, true or false. So I could create I can show you the full range of potential values that a Boolean can have. So if I create a different variable called n, and I can give that the value false. Now, having variables and objects in memory that can have the value true or false may not be extremely obvious at this stage why that's so useful, but as we go through future lessons and tutorials, you will see how frequently this is actually used and how useful it can be. So we've got 4 different types of data that we've created, and we've assigned to them variables which refer to them. They're in the memory of the computer, and we've got variables refer to them. We've got a, which refers to an integer 9. We've got p, which refers to a float 2.7. We've got m, which refers to a message hello, and we've got y, which refers to a Boolean true. Okay, so we stored some things in the computer's memory. That's nice, but now we want to look at actually doing something with the objects that we've stored in the computer's memory. And what we're going to look at is some basic arithmetic operations using operators, what are called operators. So if I create another integer, I'm going to create an integer called, I'm going to clear this. So we'll get a nice clear screen, and we'll sort of start from the beginning. I'm just going to create my integer a again. And I'm going to create another integer called b. Okay. And now we've got 2 integers, we will confirm b is indeed an integer. And we're going to do some arithmetic operations. So if I do a plus b, Python returns to me 11, that makes sense because that's 9 plus 2 is 11. Of course, I can also do subtraction using the minus operator. That's b, so a minus b gives me 7. Okay, I can do multiplication using the multiplication operator. A times b, which gives me 18. It's good because 2 times 9 is 18. And I can do division using the division operator, which is a divided by b. Now, it's important to notice here that you might have been expecting that a divided by b, 9 divided by 2, would have given me 4.5, but it didn't. It gave me 4, and that is because Python has done an integer division. It's divided an integer object by an integer object, and it's assumed that what I want in return is another integer object. And so the nearest whole number integer that you get if you divide 9 by 2 is 4. So it's given me an integer 4, and it hasn't given me 4.5 because 4.5 would need to be stored as a floating point number. Okay, so this is something you've got to watch out for when you're using integers in Python. So there's a couple of ways that you can deal with this. You can, well, I'll come back to that in a second. Let's look at doing this with a float and see what happens. So, I mean, similarly, obviously, if I create my floating numbers, so I'll create my float p equals 2.7. We've looked at that before. If I take my float p, I can also multiply, divide, add, subtract floats and integers together. So we could do p times b, 5.4, and although we've multiplied a float by an integer and it's given us an output which is a float, and we could do p divided by b, so 2.7 divided by 2, and you'll notice even though we've done a division as we did before, we're now getting back a floating point number. So whenever you multiply or divide or add or subtract a floating point number to an integer, Python always returns you a floating point number because floating point numbers are slightly more flexible. And don't forget, you can of course define an integer as a floating point number. So if I was to create b again, and now I'm going to define, instead of defining it as 2, I'm going to define it as 2.0, and then I inspect the type. Python has defined the number, has now stored b, the variable b, as a float instead of as an integer, because I put this 0.0 on the back end of it here. So if you're using an integer in a scenario where you think it might be possibly multiplied, divided, added or subtracted to a float, it often makes sense to define it in the first place as 2.0 rather than 2, or n.0. Which automatically makes it a float, and then you won't run up against integer division. So if we do a divided by b again now, we now do get 4.5 because a is still an integer, b is now a float. Another way that you can solve the integer division problem, if I, for example, let's just turn b back into an integer quickly, b equals 2. I can do something called typecasting. So you can force Python to interpret one type of object as another, if it's compatible for them to do so. So for example, I could do a divided by b, now I'll get 4. Okay, an integer division, but if I did a divided by float b, I'll get 4.5, because what I've basically done here is I've said take the variable b and try, if you can, and turn it into a float, i.e. 2.0, or store it as a float, and then when it does an integer divided by a float, you'll get a float back. So that's just something to look out for. Interestingly, if we look at some other types, if we look at our string again, if I create a variable m and an object in memory, a string object in memory, which is hello, and I create another one n, and I call that world, you can actually apply operators to strings, and you need to have a play with this to see how they actually what applying operators to strings actually does. But if I do m plus n, it says it returns a string hello world, and you see it looks kind of ugly. It doesn't have a space in there because it's literally just stuck those two strings together. I could of course have done m plus a new string which just contains a space plus n, and then I get a nicely typeset hello world message. And you can actually do multiplication of strings. It does something quite funny. If I do m times 3, you'll notice I just get 3 hellos printed, stuck together one after another. Hello, hello, hello. So you can use operators as strings as well, but just it's interesting to have a little play with that and see what they do. I'll let you go through the other ones. And of course you can actually also apply operators to Boolean values. So if I put y equals true, n equals false, these will then actually do logical and or operations and things like that. So if I do y plus n, I'll get back 1, which is true. So a true plus a false is a true. If that makes any sense. That's I'm not going to go into that in any more detail really, but if you're interested in Boolean logic, then you can Google that and take a look. It's not something we're going to be using a huge amount. What else? Oh yeah, the other operator, which I've forgotten to mention, but which you might find which I think you probably will find useful. So if we just come back to our numbers again, so what have we got? A is 9, B is 2. You can calculate powers. So if I do A multiplied, let's do 2 multiplication symbols, B, that gives me A to the power B, which is 9 squared, which is 81. And of course I can do higher powers. You can do any power. So to the power 10. Okay, get a much bigger number. And obviously you can do square roots like that. So the square root of 9 is 3. Notice that because I've used 0.5, which is a float, I've got 3.0 back instead of 3. It's actually returned a float. And of course, at the moment I've just been typing these commands in and looking at the output. Of course, often you want to store the output as a new variable. So for example, I could create a variable called c, and I could say equals a times 0.5. And so we've got an object in memory referred to by the variable a. Here in this line above, we've taken the square root, the power to the power 0.5, and it's returned us an answer. But here I'm doing something slightly different. I'm taking the square root again, a to the power 0.5, but instead of just printing out the answer to the console, what I'm going to do is I'm going to tell it to store that in memory and give that its variable name c. So now we have a new variable in memory c, which we can look at and recall and do other things with it, like for example Okay, create another variable called d equals c times 2. Okay, and we can put d. And so this is of course why you would want to create variables and put them in memory in the first place, is so that you can recall them and use them later on. Okay, I think that'll do for the first video tutorial. That is a quick overview of primitive types and basic arithmetic operators.